welcome to lesson 6.1, periodic functions. This is the start of our sinusoidal functions unit, and it's our second last unit in the course. For the warm-ups at 6.9 today, I just want you to watch. You don't necessarily need to do this. We'll just do this together as an explanation to start to explain periodic functions. So our question says, draw a graph of a person who rides 2 rotations on a Ferris wheel that is 10 meters in diameter, and assume that when they start seated at the bottom, your head is 2 meters.
Mr. Taylor, call for 319. Mr. Taylor, call for you on first 319, please.
Well, we're going to have a nice ride, okay? So we assume that at this point we are 2 meters. That's the smallest distance or height we can be. If we know the diameter of our Ferris wheel is 10 meters, that means when we get to the top, as we go around, when we get right to the top, ladies and gentlemen, how high are we going to be? That's going to be 12 meters. And again, we're halfway up or halfway down, we're going to be 2 meters plus half of the diameter, which is your radius of 5. So 2 plus 5 is 7 meters. 7 meters. So as we go around the rotation, guys, basically, we can plot them as we go. We're going to start at 2 meters, and then it goes 7 meters. Go to the top and be at 12 meters. Come back down and be at 7 meters. And to complete one revolution, we'll be back at 2 meters at the bottom. But we're going twice around, so then we're going to go back to 7 meters, all the way up to 12 meters, coming back down 7 meters, and to 2 meters. Okay? So notice, guys, there's some repetition going on here.
Mr. Taylor, call for 319. Mr. Taylor, call for you on first 319, please.
So let me try to plot this rotation and our height. I want you to remember a couple of things. So first of all, when we first got on, we were at 2 meters. Then all the way through, we were at 7 meters. Halfway through, we were at our highest point, which was 6. 3/4 of the way, we were back at 7 meters. After completing one full rotation, we're back at the bottom again. And again, we went a 5/4 rotation, which is 1/4 rotation, we'll be back at 7. Then for 6/4, which is a turn and a half, a rotation and a half, we're back at the top. And then 3/4 and back at 2. What we want to do, folks, is notice that if I join the dots in a smooth curve, this is called a periodic function. Periodic function is like something that repeats and it continues as we go left to right. Okay? So the question says, what do we notice about this pattern? We notice that it repeats itself. Okay? And we notice that there's some symmetry. Right, let's take that on to the part of the lesson that we're going to learn today. Okay, so we're going to introduce the periodic functions, and I'll tell you how it relates to sinusoidal functions. Okay. So a periodic function is today's title, guys. A periodic function, ladies and gentlemen, produces a graph that has a regular repeating pattern over a constant interval. Okay? So imagine like a wave-like motion, okay? Anything that music quite often has repeats in it, physics will use this. So if you're thinking of getting into the health chemistry, even a heartbeat, ladies and gentlemen, has a rhythmic pattern or a periodic function, okay? But when we take a look at the wave motion of, say, the sound and the light, their wave, the way you receive sound is through waves as well, okay? So let's take a look at some pieces of terminology that are going to be significant in this course, of this unit. Okay, the cycle is the periodic function part that repeats. So it's one piece of the graph. It's one cycle. Okay? And notice that it repeats itself after the one cycle, and so cycles over cycles over cycles create these periodic functions. Okay? Whereas the period, ladies and gentlemen, is the change or how long it takes to complete that one revolution around one cycle. Okay? That is the number. And very often you get people that make a mistake on the unit test because they get the cycle versus the period mixed up. The period is how long it takes to trough or the minimum point down here. Okay? Alright? And then we do what's called the equation of axis. It can be found using the formula, and the axis is going to be halfway between the minimum and the maximum. So y equals max plus min divided by 2. Well, I use one example that I just did in the warm-ups, ladies and gentlemen. I noticed that my axis was up here at 7 meters, because that's where the center of my Ferris wheel was. And I started at 2, and so I started at 2, I came up to 12, I came back down to 2, came back up to 12. And you should notice that the hills and the troughs are the same distance from the axis. Okay? So if you take your minimum, which is your lowest point, which in this case, in our case of the example, is 2 meters, we take our maximum, okay, that was 12, okay, and you add them together. So y in this case would be 12 plus 2 divided by 2, and that's going to give you y equals 7. And again, that was the scope, or where the Ferris wheel started turning. Okay? Alright. Just remember, guys, that the axis is going to be halfway between the min and the max. So that's what we're between the max and min. Alright, let's keep moving on. Another piece of new terminology is called the amplitude. The amplitude is the vertical distance from the axis to where the min or the max. So in this case, if you draw it in blue, that's the amplitude there. It's going to be the same at any point between the max and the axis and the min and the axis. Same value. Okay? And in order to find the amplitude, the easiest formula I like to use is you take your maximum, subtract your axis. You can also take the axis and subtract your minimum. It's just easier to remember this one because usually your maximum is more positive. I know it says video, ladies and gentlemen. I'm going to try that at the end to make sure that sound is sometimes an issue when loading this. If by chance at the end of the video I can't do it, just please copy and paste that link out, and then you can watch that YouTube video. Alright, let's just continue on with this example before we do that, though. It says determine the range, the period, the equation of axis, and amplitude of this function. So again, we've got a different Ferris wheel example here. And let's take a look at what we know. First of all, we need to find where the symmetry point would be, i.e. where we have the maximum and where we have the minimum. So first of all, I notice I had a maximum up here. So max value of, looking at this graph of 13, so max equals 17. I'm looking at a minimum value. You can choose any one of these folks. This is my minimum. Okay. And our minimum is 1. So remember, guys, to find my axis equals the max plus the min divided by 2. Let's plug that in. So we got 13 plus 1 divided by 2, y equals 7. Okay? Alright. And now I'm going to take a look at finding the amplitude. Okay? Amplitude is the time it takes to get the difference between the max and the axis, or the axis and the min. So I'm going to look at amp equals the max, subtract the axis, and figure that out. It's going to be 13, subtract 7, which means 6. So what does that mean? That means from here, if I go down 6, 1, 2, 3, 4, 5, 6. Amplitude likewise, if I go down here, amplitude is the same. Okay? And if you're trying to find out where my axis was as you're down there, that's the 7 that we just calculated. Okay? Alright? What else do we need to do here, guys? We need to do a period. So the period is the length of time it takes for one revolution. So we figured out that that's on the axis. So when does it come on the axis again? We'll take a look how long it would take to get one complete revolution. It is 40 seconds. So you can go axis to axis, or you could go maximum to maximum. So we went from 10 seconds to 50 seconds. Or you can even do minimum to minimum. It took from 30 to 70 to complete one revolution. Regardless of where you start, as long as you get another thing called symmetrical point beyond that, case period in this case equals 40 seconds. Okay? And just like other functions, ladies and gentlemen, your range is based upon your minimum and your maximum values. So in this case, when you're dealing with range, you want to find the minimum and maximum because y belongs to a set of real numbers such that a minimum has to be less than or equal to y, which is less than or equal to the maximum. So we already know those values, so we can set them again to be very specific about this for real example. Okay? So in this case, we've got height instead of y, so we'll say that height belongs to set of numbers such that the smallest height of my minimum, which is 1, has to be less than or greater than my height, and has to be less than or greater than my maximum, which is 3. So that would be the range for this situation, just because in this case our grass is height. And still accept because you're down languages. All right, ladies and gentlemen, there's a good start, an intro to periodic functions. Where we're heading is sinusoidal functions is any transformation between what we call the sine x curve and the cosine x curve. We'll be doing that with an investigation next class. However, before we go, here's your homework. Page 352, numbers 1, 2, 4 to 10, and 11 to 12. And I'm going to try to play this video, ladies and gentlemen. I'm hoping the video will kick in. I just have to make sure that volume turned around here. I got to unplug my mic. Again, I'm going to give it a try. If it doesn't work, then please, by all means, try to link yourself. Okay? So give me a second here, guys. We're going to get loaded. There you
go. Please. There you go.
We're going to be introduced to sinusoidal functions. They're a special type of periodic function. They still repeat at regular intervals, but their graphs form symmetrical waves. So let's look at some sinusoidal functions. We have 4 displayed here on the screen. Notice they are all symmetrical waves. And the symmetry that you see in the trough is mirrored by the symmetry you see in the crest of each of the waves. On this screen, we've shown you 4 other graphs, none of which are sinusoidal. The top 2 are periodic. They do repeat at regular intervals. But if you notice, the symmetry that you see in the troughs is not mirrored in the crest. The 2 graphs below are neither sinusoidal nor periodic. They do have that wave-like pattern, but they're not repeating at regular intervals. There are 3 terms that we use to describe sinusoidal functions. Those terms are period, sinusoidal axis, and amplitude. Let's start with the period. A cycle of a sinusoidal function is the portion of the graph from one point to a point at which the graph starts to repeat. The period is the change in the independent variable corresponding to one cycle. The easiest way to determine the period is to measure from the top of one crest to the top of the next crest, or another way of saying it is from one maximum to the next maximum. You can also determine the period by going from one minimum to the next minimum. The sinusoidal axis is the horizontal line that is found halfway between the maximum, the top of the crest, and the minimum, the bottom of the trough. Sometimes it's difficult to determine the equation of the sinusoidal axis directly from the graph, so we use the following formula. The equation of the sinusoidal axis is equal to max plus min divided by 2. Typically, it's y equals the max plus min divided by 2 if our dependent variable is y. The axis to the maximum or to a minimum. Sometimes it's difficult to determine the amplitude directly from the graph, so we use the following formula. Amplitude is equal to maximum minus sinusoidal axis. You may be struggling to understand the three definitions that you just been supplied. Why don't we take a look at a couple of questions where we're asked to figure out the period, the equation of the sinusoidal axis, the amplitude, intercepts, and the range. Here's the first graph we'll be looking at. As previously mentioned, the easiest way to determine the period is to measure from the top of one crest to the top of the next crest, from one maximum to the next maximum. Trying to illustrate this with the blue line that's shown. So we start at a maximum at 5, and we go to our next maximum at 25. We covered a horizontal distance of 20, so 20 is our period. The next thing we'll look at is the sinusoidal axis. The sinusoidal axis is halfway between the maximum and a minimum. We can read it directly off this graph. Our maximum is at 4, our minimum is at -2, and halfway in between is at 1. So we write the equation as y equals 1. You can't simply just say 1, you must say y equals 1. The sinusoidal axis is still highlighted in orange. We're now going to find the amplitude. The amplitude is the vertical distance from that sinusoidal axis to a maximum or minimum. I've drawn in the amplitude using 4 vertical lines. In all cases, the vertical distance on those lines is 3 units. So we say the amplitude for this function is 3. We're then asked to find the y-intercept. Well, the y-intercept is the point where the line intersects the y-axis. We can see that that occurs for a y value of 1. So we simply say our y-intercept is 1. The last thing we're going to find is the range. The range describes all members of the second set. In this case, our second set, or dependent variable, is y. So we want to describe all y values. Well, our largest y value is 4, and our smallest y value is -2. So it's all real numbers between -2 and +4. So let's recap what we've learned about this sinusoidal function. It has a period of 20. The equation of the sinusoidal axis is y equals 1. The amplitude is 3. The y-intercept is 1. And the range, our y values are all real numbers, where those y values are between and equal to -2 and 4.
That is the lesson, ladies and gentlemen. Let's see if I can do this.